Hello everyone, in this video we are going to learn about chemical bonding. We know that all living things are made up of cells. Like that, in non-living things, all non-living things, which means all matters are made up of atoms, because atoms are the smallest units. We cannot break atoms into further pieces. One or two atoms join together form molecule. For example, if this is an atom and this is another type of atom, then these two atoms approach to each other, a new molecule forms. Have you ever thought about why or how atoms are joining together to form molecule? Because without any force, without any attraction force, it is not possible to join these two atoms, isn't it? Yes, there is a strong attraction force between these two atoms, and that force is called as chemical bond. So in a chemical reaction, there are two main phenomena will occur. They are bond making and bond breaking. For example, if this is a molecule and a new atom approaches this molecule, the bond between these two atoms will be broken up and a new bond is formed. Between these two atoms, a new molecule formed. So this is how chemical reactions are taking place. In any of the chemical reaction, these two phenomena will occur. Either bond will be broken up or a new bond will be formed between atoms. Okay, so okay, as I told you already, chemical bond is nothing but a strong chemical force which keeps or holds atoms together. Why atoms are joining together to form molecule? Because without any reason, it is not possible to join those two atoms, isn't it? So, to attain octet state. Okay, octet state. What is the octet state? Octet state is nothing but the outermost orbital of any atom should be fulfilled with electrons. Then only that particular atom will be very, very stable. So, I have taken sodium and neon as examples. Okay. So first we will consider about sodium. The atomic number of sodium is 11 because the number of proton is 11. In a neutral atom, the number of protons and electrons will be equal. Then only the atom will be in neutral state. So here sodium has 11 protons. So it has 11 electrons in the orbital. We know that protons and neutrons will be occupied in nucleus, and electrons are presented in the orbitals which are surrounding the nucleus. So in the first orbital, maximum 2 electrons can occupy, as well as in the second orbital, maximum 8 electrons can occupy, and remaining 1 electron will occupy in the last shell. So one thing I should tell you that the last outermost orbital is called as valence orbital. So valence orbital is nothing but the last orbital of any element. Okay, so it is called as valence orbital, as well as the electrons which are presented in valence orbital are called as valence electrons. See here, sodium has only 1 electron in the valence shell, so it has only 1 valence electron. Now consider about neon. The atomic number of neon is 10, so it has 10 protons and 10 electrons. So the 10 protons and 10 neutrons will occupy in nucleus. Remaining 10 electrons will occupy in 2 orbitals. So in the first orbital, 2 electrons will occupy, as well as in the second orbital, which means in the valence orbital of neon there are 8 electrons. So the maximum capacity of second orbital is 8 only. Neon has sufficient of electrons to fulfill its valence electron. So when an element or when an atom has fulfilled outermost orbital, then only it will be very, very stable. For example, if you are feeling hungry, will you be very, very stable? No, you will be seeking to have food, isn't it? Like that, elements also, when they are having empty or any vacancies in their valence electron, then they will not be stable. So to attain the stability or to attain the octet state, they will be seeking to form chemical bonds with any other elements. So because of that reason only, elements or atoms are making bonds with any other elements to form molecules. Okay, so in those days, before 1960, there were so many questions. why atoms are joined together to form molecules, how they are joining, as well as why there are particular combinations available. Because we have heard about carbon dioxide, carbon monoxide, CO2 and CO. Okay. So we haven't heard about CO3, CO4, carbon trioxide, carbon tetroxide, carbon pentoxide, isn't it? Because in nature itself there are only possible combination, isn't it? So to answer those questions, two scientists involved doing research. Okay, so they are Lewis and Person. Okay, so now we are going to learn what they have postulated, which means what they have stated in their experiment. Okay, so first we are going to see about Lewis. So an American scientist, he involved to answer those questions. Okay, so initially he pictured atomic structure with like this one. Okay, so initially he took nucleus and inner orbitals, which means except last valence electron, remaining all orbitals. For example, here, so except the last valence electron, the nucleus and first two orbitals are considered as kernel in sodium. As well as for neon, nucleus and first orbital, both of them are considered as kernel in the case of neon. So I hope now you got a clear idea. So nucleus and inner electrons, this positive point, the positive part, he took it as kernel. The valence electron he pictured in the form of cube, because we know that cube has 8 corners. So what he was trying to say with this picture is in valence orbital, which means in the last orbital maximum 8 electrons can occupy. Okay, so if any atom has less than 8 electrons, then that particular atom will make bonds with any other elements to attain octet state. Okay, so look at this picture, just understand what I'm saying. Okay, so nucleus and inner orbitals he considered, and he called that positive part as kernel, as well as the last valence shell he pictured in the form of cube, because cube has 8 corners. So in the valence shell or in the last shell, maximum 8 electrons can occupy. If any atom has less than 8 electrons, it will make bond or it will form a nucleus to attain the octet state. Okay, we have seen how Lewis explained the atomic structure with kernel and cube-shaped valence orbital, because with that cube-shaped valence orbital, he explained maximum 8 electrons only can occupy in the valence orbital. Now we are going to see the 4 postulates of Covalent theory. First postulate says halogens and alkali metals are separated by noble gases. We know that first group elements are called as alkali metals, as well as the 17th group elements are called as halogens. Alkali metals have only 1 electron in their outermost valence shell. Halogens have 7 electrons in their valence shell, because alkali metals should transfer or should lose their electrons, 1 electron, to attain the stability, as well as halogens should receive or should gain 1 electron to attain the stability. So as per the first postulate of Covalent theory, he told halogens and alkali metals are separated by noble gas. Second statement, or second postulate, formation of negative ions from halogens and positive ions from alkali metals is associated with gain or loss of electrons. See, look at this picture. Here the atomic number of sodium is 11, because okay, in the previous chart we have seen, no? So the atomic number of sodium is 11. So the atomic structure of sodium will be looking like this only. It has only 1 electron in the outermost shell. As well as neon has 10 electrons. So first 2. Okay, so look at these first 2 orbitals of both sodium and neon. They both looking similar, no? So instead of writing sodium, we could write neon 3s1 because in the third shell, in the third orbital only one electron is occupied. Due to that, instead of writing so, we could write neon 3s1 to indicate only one electron in the valence shell. As okay. So if sodium loses this electron, which means the valence electron which is there in the last 3s1 orbital, if it loses this electron, it will attain the electronic configuration of neon, isn't it? So if sodium loses this electron, it will attain the electronic configuration of neon, which means it will reach octet state or it will gain stability. As well as chlorine. Chlorine, the atomic number of chlorine is 17. It has 7 electrons in its valence shell. If it gains 1 electron from any other elements, for example, sodium. If it gains that excess of 1 electron which is there in sodium, then it will also attain octet state. See, look at that Cl, which the electron which came from sodium is attracted by chlorine, and chlorine will become of negative ion. So as per the second statement of causal theory, the formation of positive ion from alkali metals, formation of negative ion from halogens are associated with loss or gain of electrons. Okay, and the third statement says negative and positive ions thus form to attain noble gas configuration. Okay, so by losing of 1 electron in alkali metal, by gaining of 1 electron in halogens. Okay, so both of them, by losing as well as gaining of electron, both of them attain stability because they got fulfilled valence shell. And the fourth statement says negative and positive ions are stabilized by electrostatic force. What is that electrostatic force? That is nothing but that's the strong chemical bond which is formed between positive sodium and negative chlorine ion. Okay, so these are the 4 postulates of causal theory. So first postulate says alkali metals, halogens are separated by noble gases. Second point says the formation of positive ion from alkali metals, negative ion from halogens are associated with lose or gain of electrons. Third point says by losing and gaining of electrons, alkali metals and halogens are attaining stability because of fulfilled outermost orbital. And the last point says negative and positive ions are stabilized by electrostatic force, that is nothing but a strong chemical bond between positive alkali metal and negative halogen. Okay, so these are the 4 postulates of causal theory. We have seen about the postulates or the atomic structure of Lewis theory, and also Lewis has given some symbols. Lewis has given symbols also for all elements. Okay, so with the symbol he put dots. Okay, so see, look at lithium, beryllium, boron, carbon, nitrogen, oxygen. So these are the first period elements. Period in the sense the horizontal line, isn't it? There are 7 periods in periodic table. So he has taken, okay, so here I have taken second period elements. Okay, so in lithium there is only 1 electron in the valence shell, as well as in beryllium 2 electrons, isn't it? So Lewis, to indicate the number of valence electron, he put dots, number of dots. Okay, so with the symbol of those particular elements. Okay, so look at this, lithium has only 1 electron, so there is only 1 dot, as well as beryllium has 2 electrons in its valence shell, or we could say beryllium has 2 valence electrons. So to indicate the number of valence electrons, he put 2 dots. As well as for boron, 3 valence electrons, carbon 4 valence electrons, nitrogen 5 electrons, oxygen 6 valence electrons. So this notation By using this notation of Lewis, okay, we can easily come to understand, or we can easily visualize the number of valence electrons presented in that particular element. Okay, so we have seen the atomic structure of Lewis as well as the notation, atomic notation of Lewis. Okay. Next we are going to see about covalent bonding. So covalent bond is nothing but, okay, so we already seen what is the bond. Bond is nothing but a strong attraction force. So here in the case of sodium and chlorine, here these two positive and negative ions are stabilized by strong electrostatic force. This force is formed by losing or gaining of electrons. Okay, we have seen the postulates of Covalent, and also we have seen about the formation of sodium chloride, which means alkali metals and halogens. Next we are going to see about covalent bond. Covalent bond is nothing but it is also a strong force which holds and which keeps atoms together, and these kind of bonds will form by sharing of electrons. Here the bond or the strong electrostatic force which is formed in the case of alkali metals and halogen is by transferring as well as by receiving of electron. But in the case of covalent bond, they will share their outermost valence orbital. For example, you and your friend are planning to go for a park. You have 11 rupees and your friend has 9 rupees. But the bus ticket fare is 10 rupees. So what you will do, you will give your excess of 1 rupees to your friend, and both of you will buy the ticket and both of you will go to park. So this is how these kind of bonds are formed. But in the case of covalent, for example, you have 5 rupees, your friend also has 5 rupees. Both of you are feeling hungry, so both of you are going to buy a chocolate in a shop. But in that shop, only 10 rupees chocolate is there. So what you will do, both of you will share your 5 rupees and you will buy 10 rupees chocolate, and both of you will share equal half of the chocolate. This is how covalent bonds are formed. Okay. So look at this picture. The formation of Cl2, chlorine molecule. Okay. Because we came to know that chlorine has 7 electrons in its outermost orbital. Okay, so with the help of Lewis notation, I am going to explain the formation of covalent bond in different compounds. So first, chlorine has 7 electrons in its valence orbital, which means 7 valence electrons are presented in chlorine. So it needs only one more electron to attain the octet state. Then only the outermost orbital will be fulfilled with the electrons. So it will be in a octet state, or it will be very stable. So what it will do, it will make another it will make a bond with another chlorine by sharing of electron. See, this chlorine has 7 electrons and this chlorine also has 7 electrons. So both of these chlorines will share their only one outermost valence electron, because they are not sharing all their 7 electrons, because they need only one electron, no? So they will share only one valence electron with another chlorine. Okay, so one chlorine will share its only one valence electron with another chlorine, and they will make a molecule. Okay, so they will form a molecule that is Cl2. Okay, so in a Venn diagram, this part refers the common or the common area for both of these, isn't it? So in this case of chlorine also, the electron which is presented in this area is common to both of them. Now look at this chlorine. Now count the electrons. So 2, 4, 6, 8. Okay, so this chlorine has 8 electrons in its outermost orbital. As well as this chlorine, 2, 4, 6, 8. Okay, this chlorine also has 8 electrons. So this is how they will get stability by sharing of electrons. So in covalent bond, not only single bond, there are multiple bonds also possible in nature itself. Okay, so here in chlorine, the formation of only one bond we have seen. So let's see another example also, the formation of water. Okay, so we know that the chemical formula of water is H2. Okay, the atomic number of hydrogen is 1 as well as oxygen is 8 as well as, okay, another hydrogen 1. So in the valence orbital of hydrogen, so the first orbital is the valence orbital of hydrogen, and the only one electron which is there in hydrogen, it is called as valence electron of hydrogen. As well as oxygen, the electronic configuration of oxygen is, okay, for hydrogen it is only 1, for oxygen the electronic configuration will be 2, 6, because it may, okay, in the first orbital maximum 2 electrons can occupy, as well as in the second orbital maximum 8 electrons can occupy, but oxygen has only 6 electrons, it needs 2 more electrons. So what both of them will do, they will share their valence electrons with one another. See here after the formation, okay, so here also in this Venn diagram, in this part, in these 2 points, there are 4 electrons are presented common to each other. Okay, now look at this hydrogen. So this hydrogen has 2 electrons in its outermost orbital. So we know that in the first orbital maximum 2 electrons can occupy. So it attained the octet state, or it attained the electronic configuration of helium, because helium only has 2 electrons. As well as this hydrogen also, okay, attained. Okay, hydrogen reached the atomic structure of helium. So okay, so the electronic configuration of helium, he got the noble gas electronic configuration. Next, look at the case, oxygen. Okay, so now count the number of electrons which are presented in oxygen, 2, 4, 6, 8. Okay, now oxygen also has fulfilled outermost orbital. Okay, so oxygen got, or oxygen attained the electronic configuration of neon, because neon only has 10 electrons, isn't it? Okay, see, neon has 8 electrons in the outermost orbital as well as 2 electrons in the first orbital. Like that, now oxygen also attained the electronic configuration of neon. So in this case, these two electrons are not involving in the bond formation. Only 2 electrons of oxygen is involving in the bond formation. Remaining 4 electrons are not involving in the bond formation. Okay, so those 2 electrons should be notated or should be written like that, and those 4 electrons are called as lone pair of electrons, because they are not involving in the bond formation. Okay, so one thing you should remember, that the valence electrons which are not involving in the bond formation are called as lone pair of electrons. See here, there are only single bonds. 2 single bonds are there in the case of water. Now look at the case of carbon dioxide. Excuse me. Okay, so the electronic configuration of carbon. Okay, so the atomic number of carbon is 6. So in the first orbital 2 electrons, second orbital 4 electrons. It needs 4 more electrons to attain the octet state. As well as oxygen, okay, the atomic number of oxygen is 8. So 2, 6. It needs 2 more electrons to attain the octet state. So what both of them will do? They will share their 2 electrons. Yes, 2 valence electrons to attain this stability. Here, carbon has only 4 electrons. Those 4 valence electrons will involve in the bond formation. See these 2 green color pictures. Okay, so those 4 green color dots will indicate the valence electrons of carbon. The red color dots are indicating the valence electrons of oxygen. So here, now look at this oxygen. It has 2, 4, as well as here 4 electrons are common to both of them, which means these 4 electrons are involving in the sharing or in the formation of covalent bond with carbon. As well as here 2, 4, 8, because there are 4 electrons in the carbon area. As well as look at the carbon, 4, 4, 8 electrons in the outermost orbital. Okay, both of them attain the electronic configuration of neon, isn't it? See here, in the in the case of carbon dioxide also, these 4 electrons, 4 valence electrons of oxygen are not involving in the bond formation. So we should put 4 dots near to oxygen to indicate there are 4 lone pair of electrons in oxygen. Here we know that only 2 electrons can make a bond. If 4 electrons, see here, these 2 electrons will make a bond, as well as these 2 electrons will make another bond, as well as this side also 2 electrons one bond, 2 electrons another bond. So in the case of carbon dioxide, there are 2 bonds between carbon and oxygen. So that is why this compound is called as double bonded compound. Okay, so in covalent bond we have seen about single bond as well as double bond. Now we are going to see about triple bond. Triple bond in the sense, if 2 electrons can make one bond, 4 electrons can make 2 bonds, then 6 electrons only can make triple bond. Here carbon, okay, so carbon has 4 electrons in the outermost orbital, which means it has 4 valence electrons. See, these 4 electrons will involve in the bond formation, but among those 4, 3 electrons will be shared with another carbon and remaining 1 electron will be shared with oxygen, because oxygen has only 1 valence electron. It needs 1 more electron to attain this stability. So carbon 2, 4, as well as hydrogen only 1. So it needs, it needs only 1 electron to attain this stability, as well as carbon needs 4 more electrons to attain this stability. Now look at this oxygen. It has 2 electrons in the outermost orbital, which means it attains the electronic configuration of helium. As well as this carbon 6 plus 2, 8. Okay, this carbon also attain this stability because it has the electronic configuration of neon. Now look at this carbon. This carbon also has 8 electrons in the outermost orbital. So it also attains the octet state. This hydrogen, it has 2 electrons. So first orbital maximum 2 electrons can occupy. So it also gained or attained this stability. So the structure of this compound should be written C triple bond C single bond H single bond H, because here the electrons which are common to each other with the electrons which are common to carbon and hydrogen are only 2. 2 electrons are common, as well as here you could see 6 electrons. 3 pairs of electrons are common to both the carbon atoms. That is why with those 3 pairs of electrons, 3 bond, triple bond can be formed in this compound. So here the bonds between carbon and hydrogen are only single bonds, but the bonds between carbon and carbon are triple bonds, because there are 6 electrons, which means 3 pairs of electrons are involving in the bond formation. Okay, so you should not forget that the formation of sodium chloride is involving by transferring as well as gaining of electrons. But in the case of covalent bond, the bonds which will form by sharing of electrons. Okay, so for sodium chloride, just remember about that bus fare, ticket fare. Okay, so your friend has 9 rupees, you have 11 rupees. But in the case of covalent bond, both of you will share 10 rupees chocolate. Okay, so if you remember, so you will not forget. Okay, thank you.